The absolute value function. It looks a bit like this. Why is it called the absolute value function? Well, when you see these two vertical lines, one that looks this like this and the other one that looks like this, when you put them on either side of a variable or a number, we call those guys absolute value symbols. And what it means is take the absolute value of whatever this thing is. So, what exactly does all that mean? What's an absolute value? Well, hopefully you recall. Maybe you've seen it in another class. The one that kind of confuses people is absolute. Well, let's start off with the one that everyone gets. If I say absolute value of -7, if you've been introduced to absolute values before, most people realize that this is a +7. So cool, good for you if you got that. On the other hand, one that's kind of tricky is if I ask you what's the absolute value of 7. Here what I find is about half the students that I confront get the wrong answer. Many people believe that the absolute value symbols just changes the sign, and therefore a lot of people believe that this produces a -7. Well, it does not. It turns out absolute values just take whatever the contents are and make them positive. So before it spits them out, it becomes positive. So absolute value of 7 is still 7. So anyways, that's how absolute value symbols work, is they take the contents and they make it positive. Now, one interesting thing, another note, a common misconception that I've seen in the past, is that some people believe that if you have something like x minus 2 in absolute value symbols, that is the same as x plus 2, or absolute value of x plus 2. I'm not sure exactly what they're thinking here, but I got to tell you this either way, this is wrong and this is wrong. Absolute value of x minus 2, you don't do anything with the signs until you're done evaluating. So until we figure out what the value is for x, we can't use these symbols. Okay, sort of like parentheses, same thing. As much as I'd like to do 3 times x plus 2 with parentheses, and I'd like to use PEMDAS and do parentheses first, I cannot add x plus 2. So the next best thing is multiply the 3 times the x and then the 3 times the 2. Okay, sorry, I digress. Let's get back on track. I wanted to tell you a little bit about the absolute value symbols because I'd like to make a table here. And if I go to make the table, it's going to make a lot more sense if you understand what the absolute value symbols do. So when I go to make this table, I'm going to go and randomly pick values for x. By the way, I want you to notice that this is called absolute value function. And from our discussion of functions in the past, functions are things where you put something in this case we put it into x, and then you get something out, and in this case we get it out of y. Okay, there's inputs and there's outputs. So it turns out that in order to make a table, we don't necessarily have to be given information. We can make some stuff up, and what we make up is what we're going to put in. The stuff that we get out, we can't necessarily make up. So I'm going to go ahead and say, what happens if I put in 2, 1, 0, -1, and -2. Those are just some interesting values that we could try here. And it turns out that if we put those in, what we end up getting out, well, if I put 2 in and I take the absolute value of +2, well, absolute value of +2, remember again, this is equal to the absolute value of x. Absolute value of 2 is simply 2, so I'm just going to put 2 there. Absolute value of 1, that 1 there, that's simply 1. Absolute value of 0 happens to be 0. What about absolute value of -1? What do you think that is? Hopefully you guessed that that's +1, and that's what we put there. And then what about absolute value of -2? I'm also hopeful that you guessed that that is +2. Now, what I want you to notice is that x does not repeat itself, but we do have some y's that repeat, and that's okay. Now, the interesting thing about the fact that the y's repeat, well, I'll show you in a second. I want to show you in a graph. This is what it looks like when you go to Desmos.com, which, by the way, Desmos is one of my favorite math sites, and you should go here and you should try graphing things with this. You will become a better math student if you play around with this a little bit. So we're going to play around right now. I'm going to try y equals, and then on my keyboard just above the return key there's a vertical line. If let's see, if I if I hold the shift key down, I get that vertical line, and then x, and then I'll do the vertical line again. If for some reason you can't get the vertical line on the keyboard, or whatever else. Oh, by the way, I'm going to change the color of this guy. There is another way to do this in Desmos. There's this guy down here. There's this button. And also, over here is a bunch of functions, and I think under miscellaneous they have, there it is, ABS. So you can always type ABS and that'll give you the absolute value. So if I want absolute value of -2, again, we expect that to be +2. And we get a, when we have y equals, we get a horizontal line, and it just happens to be at y equals +2 because it's absolute value of -2. Okay, anyways, that's one way to do absolute values. We're going to do vertical line, x, vertical line, and I wanted to show you what the graph looked like. A minute ago, what I showed you was that that when we put in x equals 1, we got 1, and when we put in x equals 2, we got y equals 2, and that matches up with this part of the graph. But I just wanted to point out that in that table we just wrote, when we put in x equaled -1, we got y equaled +1. And when we put in x equals -2, we got y equals +2. So if we put those points on a graph, this is what they'd look like. Desmos is kind of cool because it can show you this function, let's see here, in a table form. So I'll go ahead and do that, and I'll just remind you guys this is the table we were looking at a minute ago. And we can see these points in the table on the graph. Okay, just wanted to make sure you guys were with me and you could visualize all that. Now, this particular graph, it is called absolute value. Okay, this, by the way, there's a name for this, and I'd like you to write it down. I'd like you to sketch this guy on your paper, not accurately, but just a quick. Well, actually, let me show you what I want you to, how I want you to write it. I'd like you to write something like this on your paper. You're going to do something like, here's the x and the y, and then maybe if you have a different color pen, you do this. If you don't, that's fine. When you sketch this graph, this guy, the function is defined by this, y equals absolute value of x, and there's it's called the absolute value function. I'm going to abbreviate absolute value function. But there's something else that it's called. This particular function, where it just has y equals absolute value of x, it's called the parent graph. And it's called the parent graph because there are all sorts of variations on what that graph could look like. But this is the most basic version. So we call this, and maybe let me try to make it more obvious here. If you look at this guy right here, if you look at the graph, and this, if you look at this and its graph, we call this stuff, we call that the parent graph. Okay, now let's take a look and see why. It's because I can add things to this, and I basically get the same graph, I just move it around. So for instance, I'm going to try subtracting from x. I'm going to go -1, and then I'm going to go -2, and then -3, and then -4. Notice how the shape of the graph stays the same. It's just that the graph is moving. And by the way, I can also go +1, or 2, or 3, or 4. And again, the shape of the graph stays the same. It just moves in one direction or the other. Also, if I go outside the absolute value symbol and I add a number, then something happens to the graph. So I'm going to try, well, yeah, I'm just going to try it. I'm going to go ahead and say +1. And then I'm going to say +2, and then +3, and then +4. I want you to notice that the shape of the graph still remains the same. It just moves. And of course, I can also go -1, and minus 2 and minus 3 and minus 4. And all of those just move the graph around. We have a fancy name for when we move a graph around in that way. Hopefully you guys remember from geometry class that when you move a graph around in the coordinate plane, or when you move a drawing around in the coordinate plane, we call that translation. Okay, so that's what's happening here. As we add things to x or subtract them from x, we move the graph right and left. As we add things outside the absolute value symbol or subtract, we move the graph up and down. Now, it turns out that this is something we do with many different types of functions we'll encounter in this class. So I'm going to give you a more generic way to say what we're doing. If we subtract from x, a lot of times in math class we'll say x minus h. So we'll just let h stand for whatever number is being subtracted from x. And then on the outside we'll say plus k. Now, I got to be honest with you. I'm not entirely sure where h and k came from, but I can tell you this. I find them to be useful to understand how the graphs move around. The k definitely moves the graph up and down, so I like to think of that k like an animal that starts with k. Can you think of an animal that starts with k? Yeah, hopefully you agree with me. The kangaroo. So, the k, or the number outside the absolute value, moves the graph up and down. And it turns out that if you do plus 5, the graph goes up 5. If you do minus 5, the graph goes down 5. Now h is a little trickier. H, I still like to think of as an animal, but it moves us from side to side. So if you don't mind, humor me, I'm going to say that the H reminds me of a hippo because it's wide from side to side. So I'm just going to say H is for hippo. It moves the graph from side to side. Now the only thing is it moves it in a tricky way. Instead of as h getting bigger, if we have x minus h, as h gets bigger, the graph moves to the right. As h gets more negative, the graph moves to the left, as long as we have x minus h. What's not intuitive is this, is that if we have x plus 1 absolute value, and then we change that to 2 and then 3 and then 4, as the number gets bigger, if we have x plus the number, we move to the left. And that's weird. That's non-intuitive. So normally what we do in Algebra 2 and beyond is normally we have a generic formula for this absolute value function, and the way it looks is x minus h, and we do minus. And that way, as h gets bigger, 1, 2, 3, 4, and 5, it makes sense that it's going to the right as the number gets bigger. And it turns out if we do minus a negative number like negative 1, then what happens is as that number gets more negative, we move to the left. So negative 2, negative 3, negative 4, negative 5. The only thing is we hate all this writing, so instead of doing minus a negative 1 or minus a negative 2, we just do plus 2 or 3 or 4 or 5. But usually we have x minus h. When we see this, we always think of x minus h. And then outside the sign, we do plus k. Okay, so another way to think about all this is this. I'm going to go ahead and leave h and k, and Desmos lets me make sliders out of h and k, so I'm going to go ahead and hit all to turn those guys into sliders. And then when I do, I get these sliders, and that lets me just easily move the graph around. Okay, what I want to show you is this: I'm going to put a point on the graph. I'm going to put this point at h comma k, and I just want to point out that that point is the vertex of the graph. And as I move the graph around, no matter what the values are for h and k, basically what I'm doing is I'm moving the vertex around. It just so happens that I'm moving the rest of the graph with it. So even when we see y equals x minus h in absolute values plus k, it's still basically just a variation of the parent graph that looks like this. Okay, so this is still the parent graph, this guy that I have in red. Let's go ahead and get it. There we go. This guy in red is still the parent graph. Notice the shape remains the same. We're just moving it around. Now, there is another aspect to absolute values, and I'm going to go ahead and put that in a separate video for you.